Hello everyone. So let us discuss the first three problems from the latest bi-weekly contest 66 from Leetcode. So let's start with the first problem. The first problem goes like this, that you have to count common words with one occurrence. So you can just read the problem statement and it will become very intuitive to you. So the problem statement states that you are given two vectors consisting of different strings, word 1, words 2, as you can see here. Okay, now what you have to do here is you have to find out the number of strings that are common to both the vectors, as well as they should be only occurring once in both of them. So it is clearly, like, you can easily understand for the first example only, that lead code is occurring in both of them and it is only occurring once. Amazing is also occurring in both of them. Now is occurring in both of them, but it is occurring here twice, so that is not taken into account. As well as is occurring here, but it is not occurring here. So it means that you just have to find out the strings that is occurring in both of these vectors, as well as they should be only occurring once. So what's the common approach? There can be multiple approaches you can do, but the very simple is just find out the count for every string in the first vector and the second vector. You can use a map to find out the occurrence of every string in the first vector and the second vector, and then iterate over the map in the first vector. So you have made a map with all the strings in the first vector. Then you just have to check that every vector map, or like every string which you have staved in the map should be only occurring once, and the similar string should be occurring only in the word 2 map also. So that can be easily done. I just directly moved on to the code to even make it more clear. So what you can see here is that I have made two map here, map 1 and map 2. Now iterate over all the words in the first vector as well as the second vector and store the string to the integer mapping. So it means that, let's say, lead code occurs 2 times in the first vector, so just store that lead code is occurring 2 times. So this map is just storing how much time every string is occurring and how much time it is occurring in every vector, like the 2 vectors individually. Now what you'll do, you'll find out the total number of common strings. You will iterate over any one of the vectors, like the map, sorry. So I just iterate over the map 1, and I just have to check that the string that I'm talking about should be occurring only once. So I'm iterating over the map 1. So map.second will tell me that if I'm iterating over, let's say, any of the string, what is the frequency of that? It should be equal to 1. And the similar string in the other map should be also occurring, and the frequency of that should be equal to 1. So the let's say that I am talking about any of the string in the first map. So i.first will give me the string itself, and i.second will give me the frequency. So the frequency of that is equal to 1. And the frequency of the string I'm talking about in the other map, so m2, should be equal to 1 as well. In that scenario, both of the strings, like this string is occurring in both the maps, and the occurrence of both of them is equal to 1, then only will increment the count and just print out the count. So that's a very simple approach for finding out how many total strings are there that is occurring in both of them only once. So there can be multiple approaches also, but you can use this. Okay, so let us move down to the second problem. The second problem goes like this, that you have to find out the minimum number of buckets required to collect rainwater from houses. So I'll directly move down to the problem part. You can read down the whole thing, but it states that you are given h and dot strings. So as you can see, there are some h, there are some dots, and so on. Now you have to place buckets in them. Like, you can place bucket in any of the dots. In any of the dots you can place a bucket. Now if you place a bucket that is adjacent to an house, so every house can discharge some water. So the house can either discharge the water to the left or right. Okay, that is not compulsory that it is on the left or right. It can discharge any way, left or right, but there should be a bucket to catch that. Okay, so like if on any side, or either on the left or the right side, there's a bucket, then it is good. Okay, like the bucket can collect the discharge. It should not be like necessary that it should be on the both side. It can be on any side, and then the person in the house can discharge water on the bucket side. So my main thing is that you have to place buckets around the houses such that there should be at least one bucket around each house. Like if you talk about any of the house, there should be at least one bucket around it. And you just have to tell that how many minimum number of buckets are required to be placed around the houses, so that like all the houses will have a bucket around them, at least one bucket. And if it's not possible, then you have to return -1. Now first thought about the case that what is the -1 case. Okay, let us go over the examples, and that generally will provide us some of the -1 cases also. So you can see that, okay, if there is some continuous h's, So the middle h will have no place to put a bucket on either side. So in that case, it is a -1. Okay, so if they're continuous h's, then it was very difficult. Okay, the other case can be like if there's only one h, then also. So if there is no position for every h to be on the left and right side, then it is very much not possible. So I think so, like when I was thinking about the solution of this problem, I think that why not use some sort of a greedy approach, because greedy approach can be used. I don't think so that dynamic programming is applied here. Though it can be used also, but I think so that greedy can be easily done. So what I've done here is, I'll show you. Okay, sorry. Yeah. So let us draw out some random case and then it will become more intuitive to you. So h dot 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 h dot dot h dot h. Okay, and you have to place some minimum buckets around them. Okay, now what you can do here is that you just iterate over from left to right. Okay, this is the I, and what you'll do here is that check that whether it is like if you are on a h or not. So h means that you are a house. Okay, if you are an h, now for h you just have to you have to just check that whether there's a bucket on the left side or on the right side. Okay, now because I'm moving from left to right, I am doing the operation such that all the houses till this point should be satisfied. Okay, because I will not move any further if no house till that point is satisfied. So it means that if I'm moving to this house, I am guaranteeing that all the house before should be satisfying. So how can I do that? So let's say that I am on this house. I will first check that whether there is a bucket before it. So because I'm moving from left to right, let's say that I have put a bucket at this point. So if I come to this house, because all the house before them are satisfied, it might happen that there's a bucket before that. And if there's a bucket before that, then we don't have to satisfy this house. This is already satisfied. So the first thing you can check that whether there's a bucket before that. Okay, if there's a bucket before that, then this house is already satisfied. If this is not satisfied, then I have two options. I can place a bucket next, like on this part, or I can place a bucket on this part. Okay, like at which it is obviously better to place a bucket at this part, because that bucket will maybe help out another house that is ahead of it. Okay, so this is a better position, but it can happen that there is a house also at this point. So if there's a house at this point also, I can only place a bucket before it. Okay, but to place a bucket before it, there should be some space. If this is the first house, I cannot place a bucket before it. So in that case, this is a -1 return, because there's a house ahead of this also, and there is no place to put a bucket here. So this is the -1. So if there's a dot here, I can place a bucket here, and that is good go. But if there's a house also at this point, then it is also not good. So you just have to check that. These are the simple conditions you have to check. I will go through the code as well. But for every h, you will first check on the back of it if there's a bucket already. If it is a bucket already, then it is good. Or else you try to put a bucket in the front of it. If there's a house already, you cannot put a bucket, so you have to put a bucket behind only. So if you want to put a bucket behind only, then it means that, and I had already checked that there is no bucket behind it. Either it is a dot or either it is a h. So if there's a h, answer will be -1. Either it is a or if it is a dot, I can put a bucket here. Okay, and if the ahead one is not a house, like this is not a house, then I can directly put a bucket here, and that is fine. And then you just have to count out the total number of buckets you are putting in this whole journey, and that's the whole solution. You can check that is giving a correct answer. So I just have written down that there can be multiple if and else condition, but I just have told you. So what I've done here is total is the total number of buckets that you will store, and then you just iterate over from left to right and check that at any point of time if the state of I is h. Now I am h. I will first check that the behind of me, I -0, is a bucket. If it is a bucket, I will just continue out because there is already a bucket behind me, so I don't have to do anything. If there is not a bucket behind me, I have to check that the I+1 exists and if it is a house. So if I+1 is a house, or if like it is a last index, so it means that I do not have any option to put a bucket ahead of me. Okay, because if I+1 is like the next house to me is a house already, I cannot put a house there, like bucket there. So I have to put a bucket behind me only. So if there is a I-1 is behind me, if there's a dot at this point, I will place a bucket. And if the behind one also is like a house or a end point, then I will have to return -1. Else, if the I+1 is a dot, exactly I can put a like bucket at that point and just like increment my total and return. Or else, if the the ahead also is not a house, like it is a house or don't have any place for a bucket, so we can return -1. And in the end, if no -1 is returned, then we just have to return our total number of buckets we have placed. So I hope you understand. You can directly pause out this part. You can easily see what is the code here. I can like pause for 2 minutes. Sorry, 2 seconds. Okay. And then let's directly move down to the third part. The third one is also like, it's not too difficult according to the second. Like in compared to second one, I don't think so it's so too difficult. The observation is required, but still I don't think so it's too difficult. What it is given here is that what you can see here is that there's a robot and there's a house. The robot want to reach a house. Now there's a grid also given to you. Now there's a starting position and ending position. Starting is the robot position, ending is the house position. Now there's a row cost and a column cost. What it actually means that let's say that a robot is at, let's say, at this grid point. Now if the robot want to go to some another grid point, the robot can move in any direction, like left, right, top, bottom, anything. Now it is given that if the robot from any row goes to some another row, then this is the cost that is incurred to that robot. What I mean by this is, so let's say that from this first row, the robot goes to second row on this path. So which row the robot has gone to? Robot has gone to second row. So take the second row, and that is the cost it will take. Now from the second row, it has gone to this. So row doesn't change, but column increases. It has gone to the first column. So the first column is 2. Now 2 is like the 2 cost is done. From the first column, it has gone to second column. So which column it has gone to? Second. So second means that this is 0, 1, 2. So second column, that is 6 is added. From second, it has gone to the third column. That is, so 3 is added. That is 7. You just have to do the addition of all of them, and that's the answer. Now, how you can think over that? I first thought that maybe in such type of problems, in this type of problems, I already told that maybe DP is required, because DP is the general option we can do. Okay, and also maybe DFS, because in DP, what I thought was that I have only 2 options, either to go to the right or to the down. Okay, that is when DP is required. But in this, all the 4 directions are required. And when all the 4 directions are there, I thought that maybe DFS is required. Okay, but when I come to the constraints, I actually got a shock that the M and N are up to 10 to the 5. It is not multiplied by 10 to the 5. It means that individually they can add 10 to the 5. So if they're individually 10 to the 5, I cannot use DFS, or even I cannot use like DP, because the grid cannot be formed with 10 to the 5 blocks. Okay, so it means that I have to do some sort of, like, I cannot store out their states. So if I cannot store out the states, then DP or DFS is not, like, we can choose them. So I generally thought to like draw it out and like see what observations I can make. So what I find out here is, so let's say that if I draw some grid. Okay, I just take some random values. I am not talking about the real values, but let's say that this is the X I am standing on, and this is the house. Okay, now what you can easily understand, or what you can see here is, so let's say that if I go from this block to this block, the cost I will be like, which I will be having is, so let's say this is 0, 1, 2, 3, 0, 1, 2, 3, which means that I'm going to the first column. If I'm going to the first column, the cost I will be getting is, let's say, XC, like XC1, column 1, what is the value is there, I will be getting that. Then maybe I will go to this, so it will be adding XC column 2. Okay, and then I will go to this, and then I will go bottom down on this part, which is fine. Let's say that if I take this route, I will go one step back, like one step down, that is changing my row. So X row 2 is there. But then if I go this way again, the same column is taken. So the XC1 is also done, XC2 is also done. So it means that it is talking about the column difference, on which column I will land, and whatever path I will take, as you can see, I will land on the same columns, because I have to, like, if I want to go from this to this, I have to travel all the columns. So column will be traveled whatever path I will take. And like if I go down, I will talk about, like, I will travel to all the rows, whatever path I will take. And it's thus depend upon what is the difference between them. Like if this is x1 y1, this is x2 y2, I just have to go from x1 to y2, all the rows, whatever is the rows between them, I have to add them, and whatever is the y1 to y2, all the columns that are them are adding them. That is the whole trick. You just have to add all of them. You don't have to do anything. From x1 to x2, just add all the rows, and y1 to y2, just add all the columns. But there's a trick. Like there's one catch. I will just remove this out. Now, because there's one thing that the house and the column can be such that they can be in any direction. What I mean by this is, like it is, so let's say that this is 0 comma 1 and this is 0 1 2 3 3 comma 0 1 2 3 3 comma 3. So you have to go from 0 till 3, okay, and then you have to go from 1 till 2. But let's say that they can be grid in which you are standing on this and you have to go to this. Now you have to talk about, like, you have to think about all the possible configurations that then you have to go from this to this and this to this. So like the point is ki from 0 till 3 you can easily do a for loop, but from 3 to 0 you cannot know, like you do not generalize it, like from, so how much, like you are increasing it or you're decreasing it, like you are, so this is increasing or decreasing. There can be multiple cases. There can be 4 cases that I am increasing this and I'm increasing this, I'm increasing this and decreasing this, and so on, because there can be 4 coordinate positions. So it can be difficult for you. So what you have to do here is that I just only have to think over that how many distance or like how many changes I have to do. What I mean by this is, so let's say that I am going from this to this, or I'm going from this to this. It doesn't matter. Why? Because I only talk about what rows I have to travel from. Like I have to go from this to this, or I have to go from this to this. All the rows in between will be same. I have to just do the sum of them. So it means that you just have to think over ki I can like swap them out. So whatever is the, like whatever is on the left. So if this is the start point, this is the end point. If the end is such that the start is on the left side, you can either take that so that we can directly go in the forward direction. If this is the start and this is the end, I can swap them out so that it will be swapped down. Then you can like directly use this logic, and then like you can just do a 2 for loops. Okay. Also one more thing is ki what you have to also keep in mind is ki, let's say that if I start from this point and end from this point, I will go from this to this and this to this and from this to this point. So only these 3 columns are considered. The point from which I am starting is not considered. So you have to also keep in mind is ki from which point I am starting. So that's the whole thing. You have to also keep track of all of them. So I will show you in the code part so we will make it more clear. So this is what I've done here is to swap the 2 coordinates to see that, because I have to only go from x1 to x2 and y1 to y2. So you can easily do that. You just find out the minimum of both of them, because let's say I want to go from the 3rd row to the 5th row or 5th row to 3rd row. It doesn't matter. You just have to keep track of from which row I'm starting. So the minimum would be the small, like the find out the minimum of both of them, x1 and like x of the starting, like the robot start, and x of the house start, and find out the minimum of them, because from minimum you have to go to the maximum, and thus you can easily do a for loop in that case. Okay, then that's the 2 thing that I have to find out the minimum of x1 and y1 and x2 and y2, so that I can just do a for loop from x1 to y2. That's the total number of score or penalty you have to incur while you're moving down the thing. This is not required. Then what I've done here is that this if and else condition is there. So we have to also think that what is our starting point. If I just do this, I will lose track of which is our starting point, because okay, I am just talking about whatever is the starting point, just move from the smaller to the larger one. If I'm doing this, I will lose track of which is the start point. And because I have to also keep track of which is the start point, because I don't have to take that. I have already shown you that I will not take the starting point. From starting one, I will go from starting to the next one. From next one, I will go to the end. So that's what I have to do. But what I've done here is, because either the x1 is the minimum or x2 is the minimum. Like any one of them, like x1 is the minimum or y1 is the minimum from which I have started on. So what I've done is ki I will check that if the start position is equal to x1, which means that if the x1 I'm starting about is the start position, I will not take that. I will move from x plus 1 till the end. And if this is not the start position, it means the other one is the start position. I will move from this point to x2 less than 1. So is it equal to, this is less than. What I'm talking about here is key. So let's say that I'm starting from some position start till the end. I don't have to take the start coordinate, the start row or start column. I will start from the next one, because as you have seen here is that if I'm talking about this, I will jump to this row or this column, sorry. So if I'm jump to this column, I will only take the penalty or the score for this column, not this column. So if I'm doing a for loop from this row, from this coordinate to this coordinate, I will also take care of this coordinate. But I don't have to take this coordinate. I have to only take the coordinate that is the next of it. So from the start one, I have to not take them. So that's what I've done. Don't take the start one. And similarly for x1 and y2, and just add the total of them. The row, like the row cost and the total cost, is just a for loop. It does nothing much. It's also like greedy approach or just math thing. Okay, just print the total. There's not some like DP or DFS or anything out. It's very simple. Okay, so that's the solution for the first three problems. If you still have any doubts, you can mention down. Thank you for watching this video. Stay tuned for more videos. I'll send this one to see you next one. Till I keep coding, and bye.